So we have the definition of convergence for series that we can use sometimes directly in order to see that a series converges. We've seen that we can use that when we have a telescoping sum, but we've also encountered series where that wasn't immediately helpful because we couldn't find a nice formula for the nth partial sum, meaning we were unable to take the limit of that. So the first test, as we call it, that we're going to cover for looking at series and whether or not they converge or diverge is called the test for divergence. And this has the following. So if I'm looking at the sum from k equals 1 to infinity of a sub k, and we take the limit of the terms of that sum, and that limit does not approach 0, then the series automatically diverges. So first of all, notice this is very different in terms of a limit. We're not taking the limit of partial sums here. This is saying the limit of the terms of the series. So if that does not approach 0, the series automatically diverges. So in certain textbooks, this is also referred to as the nth term test. That comes from often writing it as the limit as n goes to infinity of a sub n. You're looking at the terms of the series. That's fine to call it that, but I actually prefer the test for divergence. The reason I like that is that very much emphasizes that this is only used to conclude potentially divergence. We should never take the limit of the terms and use that to conclude convergence. So I'll emphasize this again and again. So notice this is just a one direction statement. So if the limit of the terms is instead 0, this gives us no information about the series. And that's going to be very important. It's only if the terms do not go to 0 that this is helpful. So probably one of the most common mistakes in Calc 2 is seeing someone claim that a series converges because the terms go to 0. And if I call this the test for divergence, hopefully I'm very unlikely to say a series converges by the test for divergence. That's kind of the motivation behind calling this in that way. Several of the tests that we look at, you can see, can either lead to the conclusion of convergence or divergence. And that's very special about this one. This is only useful in the instance where we can conclude divergence. So let's see it in use. The other thing we'll appreciate is it is very simple to apply. For this here, notice my a sub k's are of the form k over k plus 1. I can take the limit as k approaches infinity of the terms of this series, and that limit is 1. Limit is 1, which is not 0. So that is enough work for me to say that the series diverges. And one of the things I want to kind of model here is what I expect for you all in terms of your justification. As we continue, we're going to have several other tests, and anytime you make a conclusion about convergence or divergence, I want you to briefly state what you're using for that. So part of the work that's necessary here is you finding the limit and showing that it's not 0, but also then I would say by the test for divergence. You can abbreviate that if you want, but that way, as we start to see other tests, then you're going to be able to reference a broader range of things that you might be using. So this would be a complete solution. I see that the series diverges. If I were to make one small change to this, and I changed the numerator there to 1, so this is my a sub k in this example, the terms now go to 0. And what I want to emphasize is that that means nothing to me. No information by test for divergence. Now, at this stage in the course, we don't really have anything else we can use. So the best we can at least do is know that we can't use the test for divergence. And so that's kind of the extent of what I want right now. Now, it turns out we're going to look at other tests, and we will be able to answer this. So as I start to broaden the number of tests that we're going to look at, you can imagine this kind of as stage 1. Oh, try the test for divergence. I see it doesn't work. Now, what should I move on to? And that's kind of where we're headed. And again, as it turns out, we will see, so again, we're not here yet, this series actually diverges. So like I said, it can be tempting to assume that terms going to zero means convergence. And in fact, we have here quite the opposite. Like I said, this is a statement I'm making that I can't really justify to you with what we've seen so far. So kind of the biggest takeaway here is really emphasizing what I have in red. This is a very useful test, but it's also very commonly misused. And we want to really emphasize that. In class, I'm going to focus on where this statement comes from. Why is this true? And then also some of the other consequences that we can look at with that. But again, at this point, just kind of being able to think, when can I use it and when can I not use it is going to be most useful.